Good afternoon, everybody. Thanks for coming to this iteration of the Bradford seminar series. Today we're going to have a presentation by Dr. Yukyan Lam from Tishman Environment and Design Center. My name is Nikki Sheets, and I'm a Senior Policy Fellow and Lecturer at C-PREE in SPIA. I just started recently, and Yukyan is a close colleague of mine. She told me I did not have to say a lot about her. She was very nervous about what I was going to say. But of course, I only have good things to say, and a few things I do want you to know about her. And I don't know, has her bio been circulated?
Not the website.
Okay. So let me go over some stuff quickly. Her educational background. If I get it wrong, let me know you can. This is MIT undergrad, Harvard Law School, and a PhD from Johns Hopkins. She did the law degree, and then she worked as a lawyer for several NGOs in Colombia on human rights issues. Then went back to school and got the PhD and worked for NRDC, Natural Resource Defense Council. And that is where I met her. She eventually headed up the community science program. And this is the important stuff you need to know about her. I met her at NRDC, and she was supporting the EJ grassroots movement, of which we are both now a part at the time. And she was doing a very good job of it. And when we say that from the EJ point of view, we mean both substantively and how she was working with communities. And then when she expressed some interest in working with, directly with EJ, and I don't know if she knows about this, we fought over her. Because we had several organizations that wanted her to come and work with us. The Tishman Center won out, and so she is senior scientist and director of research at the Tishman Environment and Design Center at the New School, which is one of the, if not the leading academic environmental justice centers in the country now. And Yukyan's role is very important because in the EJ movement, we are trying to get homegrown technical expertise, because right now, usually, we have to go outside the EJ movement to get that expertise. We have to go to the environmental movement and other folks who sometimes don't agree with our positions. So Yukyan is going to help us develop that internal capacity to address EJ issues within the grassroots EJ movement. And so today she's going to talk to you about an interesting topic. EPA came out with this power plant rule, and the environmental justice grassroots movement has mostly opposed it. The environmental groups have supported it, and other folks have supported it. And so Yukyan is going to tell you why. This is going to be part of our presentation. What problems we have with the power plant rule and is faced around CCS and hydrogen. So I want to thank you for coming and listening and trying to figure out what the EJ movement's stance is on climate change mitigation policy. And I want to thank Dr. Lam for coming and telling us and talking to us about what that stance is.
Okay, thank you so much. All right, I'm going to try to juggle all the devices that I have here, so wish me luck. Let's see. Okay, so yeah, as Nikki said, I'm going to talk about carbon capture and sequestration, especially as it is being proposed to be deployed in the power sector. But before I do that, I wanted some grounding, and I'm going to use Nikki's own words here, which is that for many, many years, the basic fight for environmental justice communities has been that climate policy just cannot proceed focused solely on climate goals, and that climate policy really represents an opportunity to address some fundamental inequities in our systems, in our infrastructure, in our policies. The premise is that equity and environmental justice should be an integral part of climate change mitigation policy, because that fight against climate change has the potential to transform our society, and in the process could either perpetuate or exacerbate inequalities based on race and income. So that's kind of our starting point for today. And as I mentioned, we're going to talk about the power sector specifically. Now, why are we so focused on the power sector? Well, I think for reasons that are probably obvious to many of you, right? That the US greenhouse gas emissions by sector shows a substantial contribution from the power sector, somewhere around a quarter. It depends on if you're looking at indirect or direct emissions, but at least a quarter by recent estimates and in the most recent year. And electricity demand in the United States is projected to grow rapidly due to manufacturing facilities, industrial facilities, and data centers, along with increased electrification. Now, when it comes to environmental health and justice concerns around how we are thinking about power sector climate policy, it's very important to consider that greenhouse gas emissions themselves, they don't have a direct health impact in a localized kind of way, but they often come along with air pollutants that do have a localized and harmful health impact. So mitigation approaches for whatever sector, but especially the power sector, if they are only focused on greenhouse gas emissions and fail to take advantage of opportunities to improve public health and environmental justice. Just a snapshot of some of these environmental health impacts that come with power plant infrastructure. You can see the emissions of specific air co-pollutants. By air co-pollutants, they're called co, right, because they are emitted along with the greenhouse gas emissions, but aren't themselves the greenhouse gas emissions. You have particulate matter. We have nitrous oxides like NO2, sulfur dioxide, and mercury, other volatile organic compounds, other heavy metals. And there are a range of documented health impacts, both from acute exposures to these environmental pollutants, as well as chronic exposures. You can see some of them here. They include premature death, respiratory symptoms, respiratory illnesses, cardiovascular events, potential carcinogenic effects. There are also neurological effects, immune system damage, and many, many others. There's extensive epidemiological literature that supports these points. What we've seen here is that, just as an example of some of the kind of co-location of environmental justice communities with power plants in a specific case study that we did in New Jersey, is that you can really see how there is this heightened risk, heightened health risks, whether you're looking at cancer, which is the yellow map, or respiratory hazard, the orange map here, or even some other health metrics. And what we really have honed in on is this important fact that you have to really consider environmental justice and environmental health impacts if you are thinking about how you're going to reform the fossil fuel infrastructure that currently makes up so much of our power sector. So not just our research, other researchers have also really documented the co-location of environmental justice and fossil fuel infrastructure. So for example, there was a recent study by Laura Cushing and others. They studied redlining and how redlining has been associated with increased siting of power plants in communities, even to this present day. And so what they found here is that when they looked at 196 US urban areas where redlining happened, they saw a stepwise correlation between risk grade, the number of power plants, and the cumulative quantity of power plant emissions upwind and within 5 kilometers. They found that these findings pointed towards racism in the residential housing market as something that also had an enduring impact, because the associations, they were strongest in the immediate period, the 1940 to 1969 period, but continued even to the most recent period observed, which was 2000 to 2019. Another thing that they found is that they were looking at the emissions of some of those specific co-pollutants, as I described in the previous slides. And what they found here was that even controlling for pre-existing power plants, neighborhoods that were deemed the sort of most quote-unquote hazardous, which were receiving a grade of D, they had higher average present-day emissions of nitrous oxides, sulfur dioxide, and fine particulate matter, even compared with the C-graded neighborhoods. So not even A and B, but even with the C. And those were really substantially higher. Specifically for nitrous oxides, it was 82% higher. The amount of sulfur dioxide was 38% higher, and the amount of fine particulate matter was 63% higher, comparing the D to the C. And these were all statistically significant associations. Another study that I'll point to, this was a recent study of the RGGI states. So this is the Northeast region where there is a greenhouse gas trading program called RGGI, the Regional Greenhouse Gas Initiative. That study also found, very similar to what I've been saying before, is that environmental justice communities live closer than other populations to power plants in the RGGI states. And what they found here was that the percent of people of color that live within 0 to 6.2 miles from power plants is up to 23.5% higher than the percent of white population that lives within those same distance spans. The association for poverty, the percentage of people living in poverty that live within 0 to 5 miles from the power plants is up to 15.3% higher than the percent of the population not living in poverty within those same distance spans. This kind of research really points to the very important impact of race, separate from even poverty, socioeconomic status. And this has sort of been reflected in a lot of the literature. So this is just one example of a study where this bears out. So given this kind of situation, I've kind of made the case, right, that we have to really consider environmental justice, localized health impacts when thinking about actions to mitigate climate change for the power sector and any other sector, really. Unfortunately, climate change mitigation policy in the power sector has not done that, has not really centered in its design on environmental justice. It's not been a central feature, and that is the case despite this, what I've made the case for, this co-siting of fossil fuel infrastructure, this disproportionate siting in low-income communities and people of color communities. We've seen instead the proliferation of mechanisms that are based on market-based trading, greenhouse gas trading programs like RGGI, and in California, California Cap and Trade Program. There are many other examples of these kinds of policy proposals. We've also seen the proliferation of fuels and technology that have localized impacts, supposedly because they are going to be good from a carbon standpoint, but not really considering those localized environmental health impacts. And this is unfortunate because especially those technologies and approaches that focus only on managing carbon can harm public health and environment in other ways. And policy mechanisms that allow emitters to choose between reducing their pollution locally or purchasing offsets from emitters who reduce their pollution elsewhere means that the reductions may not occur in the places that most need it, right? So it kind of makes sense if you let the market kind of decide where the reductions are going to occur, those are going to be happening in the places where it's cheapest to pollute. And often those are low-income communities and communities of color. So unfortunately, this is kind of the backdrop, right? So this was a backdrop, even up to a few years ago where we were seeing these kinds of policies being proposed as power sector climate actions. And there's now, against this backdrop, it's not that those mechanisms, those market-based mechanisms have gone away. We have a new factor, though. And this is the rise of carbon management as a new additional kind of climate action paradigm. And enormous amounts of public and private funding, along with public policies, are really driving the deployment of carbon capture and sequestration and the development of a hydrogen industry in the United States. Elsewhere as well, but we're going to focus today on the US power sector. So in May of 2023, as Nikki mentioned, the EPA came out with a proposed rule to regulate the carbon pollution from power plants, from fossil fuel fired power plants, meaning coal plants, basically, and natural gas plants. And in establishing this carbon pollution standard, EPA did a thing where it had to designate a certain technology as the best systems of emissions reductions. And what EPA proposed in May of 2023 was that carbon capture and sequestration, as well as the blending of hydrogen-enriched natural fuels, the mixing of those fuels, those would be considered those best systems of emissions reductions. Those were the two technologies that EPA kind of held up, validated, and said, hey, these are the technologies that apply, and if you are a power plant that meets certain criteria, then these are technologies, those levels of carbon dioxide reductions that you would get from employing those technologies, that's what you would have to achieve. And we became very concerned from an environmental justice standpoint, and especially because we had seen from previous literature, and now we did some additional analysis, we saw that in fact, the plants that met those criteria in the proposed rule and that would host potential new carbon capture infrastructure, they would get those upgrades to those plants, or there would be new plants built with carbon capture or with the hydrogen fuel mixing technologies. The vast majority of those plants were indeed located in or near an environmental justice community. So kind of like what we saw in those previous studies, right? There's this co-location. This is a map that kind of shows some of this early analysis where we're looking at those plants that met the criteria. And you can see almost all of them, it's over 90%, are in environmental justice communities. So that really begs the question, well, what does this mean for EJ communities, right? What does it mean to have CCS or hydrogen co-firing? What are those localized public health and environmental impacts that these communities might potentially be faced with? So as a result, we decided to conduct a pretty extensive kind of literature review to really document what is this evidence of the impacts of CCS and hydrogen co-firing to environmental justice communities as they might be deployed in the power sector at those plants. And so I'm going to share the results of that literature review with you today, and I will just briefly explain what kind of this process even means. So what is actually carbon capture? To start with, carbon capture refers to a process where CO2 is captured and separated at the point of combustion from an emitting source and then transported for use or storage. So that emitting source can be a power plant, as in the case that we're studying here. It can also be an industrial facility. To date, most carbon capture in this country actually happens at industrial facilities. It's not actually really happening at scale at power plants, but that's sort of the proposal on the table. Now, the fact that you have carbon capture storage doesn't mean that there's actually a net removal of CO2, right? It depends on what you're doing with that CO2. And it turns out that as many as 70% of CCS projects globally and 85% in the United States, that CO2 is actually going towards a process called enhanced oil recovery, which is basically, it means that you're taking the CO2 and you're pumping underground into these sort of hard to extract, getting the last bits of oil that are there underground in some of these places, and then doing things with the oil that also unfortunately have a greenhouse gas emissions impact. So really important to keep in mind that carbon capture itself doesn't actually mean it's a sort of net negative CO2. Okay, so now looking specifically at potential environmental justice impacts. The first thing that we noticed, and the EPA rule, the proposed rule, admits it itself, is that carbon capture is a very energy intensive process. The estimates, there's different studies that come up with different estimates, but one review that we found from 2022 says that that energy kind of penalty, the extra energy that you would need to power the carbon capture is between 15 to 44%, which is quite substantial. And along with that energy that you need, you will then get added emissions because chances are that energy is also being produced in a way that generates emissions. It's not like we have a glut of renewable energy sitting around that we would use to then power the carbon capture. No, so in fact, you are going to see increases in those co-pollutants because of that extra energy use. And again, as we mentioned before, the particulate matter, NOx, VOCs, ammonia, et cetera, those are all going to be increasing in relation to the fuel that's used to power the carbon capture. The other thing is that the most common method right now to actually capture the carbon, it happens post-combustion, and it's through the use of a chemical. They use amine-based chemicals, amine-based solvents to capture the CO2, and that itself is not only energy intensive, but also leads to the formation of byproducts, nitrosamine specifically, which is toxic and carcinogenic. So these form when the amine solvents and the NOx in the post-combustion flue gas react. And they can then get out into the environment by way of stack emissions or disposal of spent solvents. There's research to look at different types of chemicals that could be used for capture, but the problem is that a lot of these chemicals, there's this kind of trade-off, right? So if you get one that's less toxic, you might not be able to kind of have as much recharge, or if you get more of the recharge, you can't, it might take more energy. So there's kind of these trade-offs, and so that's why even the studies that we looked at, we found a literature review that looked at the different types of chemicals being used, and they said there were really none other besides this one that were ready for deployment, unfortunately. So this chemical contamination is another impact that's going to have localized environmental and health effects. And then finally, the thing I want to mention as relates to the capture process is, as I mentioned, there has been this new infusion of resources, policy support, funding, private and public funding. But actually, the technology itself is not new in the sense that it hasn't been around and tried and tested. In fact, there have been tax credits supporting carbon capture since 2005, and billions of dollars for demonstration projects at least since 2009. Despite this prior support, the capture rates anticipated have not been achieved. So one example of this is one of the power plants to really try to do carbon capture at scale is Petronova, which is a coal plant. It's a coal facility in Texas, and it has multiple units. And the carbon capture process was actually so energy intensive there that they actually had to build a separate gas unit just to power the carbon capture there at that plant. Now, looking at the rates of carbon capture, what was found, this is from a White House Environmental Justice Advisory Council report from 2023. As they were reviewing the literature and the evidence on this, they said that the projected high capture rates for CCS have not been produced or verified, and the predicted levels were about 90%. However, estimates place the real capture rates somewhere around 55 to 58%. In another example there of carbon capture, so this was not at a power plant, but at a ethanol plant in Illinois, they similarly recently discovered that really only 10 to 12% of the CO2 emissions were being captured by this demonstration project. So it's nowhere near the 90% that was claimed, and in fact, 90% was the figure that the EPA used to do its modeling in the proposed rule. So this is obviously very worrisome. Now, moving along, kind of the supply chain, if you will, we looked a bit at the literature on the carbon transport issue. Now, what do we know already? Well, we know already that pipeline infrastructure in this country is disproportionately sited next to vulnerable communities. So we already have that as the kind of the backdrop. What we then see when it comes to CO2 pipelines is that currently there are some 5,000 or so miles of CO2 pipelines, and the level of CO2 pipeline build-out that would be needed if we were to try to meet our climate goals, which vary, but I will cite a Princeton study in particular, estimates over 60,000 miles of new CO2 pipelines might be needed to meet the 2050 climate targets. This is concerning, especially in light of a lot of the physical, chemical, environmental risks that we found when we were reviewing what CO2 transport via pipeline really entailed here. So for one thing, CO2 is an asphyxiant, heavier than air. It can travel large distances. The properties of CO2 moved at high pressure, so their pipelines can cause fractures and rupturing. Water is very difficult. This issue of liquid water is really difficult to eliminate. And then when mixed with that CO2, that forms carbonic acid, which is actually corrosive. CO2 in high concentrations can cause respiratory complications, asphyxiation, altered mental state, and seizures. And it can also impede emergency response by stopping vehicles that run on a combustion engine because it displaces oxygen. So this actually bore out to be the case, unfortunately, in a pipeline rupture incident that occurred in Satartia, Mississippi in 2020, where 30,000 barrels of liquid CO2 were released, 200 people needed to be evacuated, and some of the emergency response vehicles and people's personal vehicles as they were trying to escape actually stopped because of the CO2 concentrations that were there. Unfortunately, that same company, which was taken over, it was acquired by ExxonMobil, experienced yet another leakage, actually in April of this year, where over 100,000 gallons of CO2 were leaked near the town of Sulphur, Louisiana. There was an inadequate alert system, and there was a shelter-in-place order for people to stay indoors. even though they recognize actually that might not have been a really good idea because sheltering in place is actually maybe not what you want to do. Unfortunately, they just were not sure where the CO2 was going to go. There was like a wind situation. So basically, it really kind of highlights the lack of knowledge. There's a lack of knowledge on dispersion of CO2, as well as just not adequate preparedness from an emergency response point of view. Unfortunately, the regulatory framework does not address these risks. And part of that is the knowledge gaps, yes, about like knowing exactly how CO2 will disperse, but also just generally, the regulations are insufficient. So as an example of that, CO2 in a supercritical state is the only form of CO2 that's actually currently regulated by the Pipeline and Hazardous Materials Safety Administration, which is the part of DOT that oversees pipelines. Liquid CO2 is not regulated, gaseous CO2 is not regulated. So if the CO2 kind of changes states at any point, then it would cease to be regulated. Unfortunately, PHMSA, that agency, is supposed to be undertaking rulemaking. It's had a commitment to do so since the incident in Satartia in 2020. Those rules have still not been made public. The proposed rule is still kind of ongoing. And then of concern, especially from an environmental justice point of view, is that the permitting and routing authority for CO2 pipelines really depends on state and local jurisdiction, and it's quite a patchwork. And with that kind of backdrop, this can lead to inconsistent levels of protection. And often what happens with the pipeline siting is that it's going to go through the communities of quote unquote least resistance, right? So those communities that have the least amount of power to resist might be the ones that end up getting where those pipelines are. Continuing down the chain, I want to talk a bit about carbon storage and sequestration. So CO2 storage generally requires a very deep injection well with constant monitoring. And even a rigorous geological assessment might not be enough to mitigate leakage problems. The amount of CO2 that could escape through slow, continuous leakage or through an acute event like a well blowout is quite significant, so much so that the risk of generating emissions from a strategy that's supposed to reduce them is far from negligible. The environmental risks include chemical contamination of groundwater and drinking water. You have the blowout risk as well. You could end up with quite high volumes of contaminated water. I wanted to point to this picture here, this example of offshore carbon CO2 storage in Norway. There are two projects in Norway that are kind of pointed to as the sort of best examples of CO2 storage. And in fact, recent news has reported that they have not been as successful as planned. So in one case, the storage lifetime actually decreased from 18 years, it was supposed to be 18 years of storage, to just 6 months. And in another case, they found that after only 3 years of operation, the CO2 actually migrated away from where they thought it was supposed to be by some 200 meters. And these two sites in Norway are actually two of the best characterized storage sites in the world. So the fact that they are still having problems is very concerning. There's also some emerging research on the impacts on seismic activity that come from CO2 storage as well. So in the US, CO2 injection operations, they are very much in beginning phases. There's only really one CO2 injection well that has been permitted by EPA. That is the ADM facility in Illinois. And this past March, this year, they found out that CO2, some 8,000 tons, leaked at that monitoring well in March of 2024. It was then later revealed that, in fact, they had had technical failures ever since 2018. So between 2018 to 2022, there were actually previous leaks and other failures. EPA knew about some of this. It knew about the March leak at least since June, but only issued a notice of violation in August of 2024. And the public itself did not know of any problems until September 2024 when news broke. So they only found out from reading the media. They didn't find out from ADM itself. They didn't find out from EPA. The issue that they found there since that incident was that it's likely a problem because of the steel. There's a 13 chrome steel, that's the name of the steel that was used, and it is just very vulnerable to corrosion when it comes into contact with liquid. And unfortunately, 13 chrome steel is the kind of steel that is very commonly used in oil and gas wells. And so what actually happened was that when EPA found out about the incident in March, it actually issued a notification companies to not use this steel for CO2 sequestration. So they actually issued a memo to companies to say, don't use this, and that's going to potentially really raise the costs and make it even less feasible that we have adequate CO2 storage. EPA has permitted 2 additional wells in Indiana. Those have not yet been built yet. So this is really the first and kind of only example that we have in the US. There's also a lot of regulatory problems, and I think everyone's kind of getting this notion that you have scientific issues, you have knowledge gaps, and you also have regulatory inadequacies. And the same is true for this carbon storage sequestration step. So CO2 underground storage is regulated under the Safe Drinking Water Act's underground injection program. And in 2014, EPA consciously made the decision that CO2 itself would not be considered a hazardous waste under RCRA, under the Resource Conservation and Recovery Act, and so conditionally excluded CO2 streams. And so this really meant that instead of having a certain set of parameters and regulations that had to be met, that one would have to meet for storing CO2 underground, there was sort of a less stringent standard. And instead of being a class 1 well, this would now go under the class 6 well. And the issue with class 6 is that EPA would normally grant those permits, but it's been in the process of giving primacy, as in handing over the authority to grant those permits to different states. Wyoming had primacy, North Dakota had primacy, and then Louisiana in the last couple of years also applied for primacy. And EPA, despite many objections from local advocates, they decided to go ahead and give Louisiana's Department of Natural Resources primacy. If you actually look at the Louisiana's state record, administrative record in the hearings on this class 6 primacy decision, every single written and public comment was opposed to Louisiana getting primacy because of the poor track record of the Department of Energy and Natural Resources. EPA went ahead anyway in December of 2023 and granted Louisiana primacy. And Louisiana right now has more proposed CO2 carbon storage projects than any other state. And in a demonstration of what really this means for environmental justice, I wanted to point to this statement by the White House Environmental Justice Advisory Council, which noted that these CCS projects, they're not even for existing operations, but are actually part of a significant expansion of new gas and petrochemical facilities. So we are taking communities that are already kind of living on the front lines and bearing the brunt of fossil fuel infrastructure. We're taking them and giving them additional risks, right? Additional infrastructure, additional risks of CCS on those infrastructure. The other really important issue that I wanted to point out is that Louisiana has some 190,000 idle and abandoned oil and gas wells that could problematically interact with CO2 wells. So what can happen is if you have like a CO2 sequestration alongside land, a topography that has a lot of other wells, you could have situations where the CO2 kind of migrates and then kind of goes up through those abandoned wells. And you can also have a situation where the different pressure zones interact problematically, and it could lead to problems like more sinkholes, which has already actually happened in Louisiana and other places in the Gulf South. So in order to really do this safely, what this really means is, first there's so many assumptions that have to, of things that have to go right to make sure you're doing this safely. So first you would have to kind of assume that these abandoned wells, we knew where all of them were. And it turns out that we don't. There are various estimates for this. We don't exactly know the number, but it's possible that the number of actual abandoned oil and gas wells in Louisiana could be an entire order of magnitude greater. And it's just these 190,000 that we actually know the locations of. So what we're really assuming is that if an operator wants to put a CO2 injection project somewhere, they're going to do some kind of aerial imagery, or they're going to do some other kinds of scans to really be able to, field surveys, things like that, to actually find out where wells are. The other assumption is you have to assume that those abandoned wells are plugged properly. Some have been plugged with wood, some have not been plugged at all. And companies are not actually required necessarily to even test that the plugging kind of works. They might just be looking at the books and seeing on the record, oh, has it been plugged? Great, that's it. There's no guarantee, there's no kind of regulatory mandate that they have to test to actually see that it is sufficiently plugged. And then even assuming that they plugged it with steel and cement and not with wood or not at all, you'd have to assume that that steel and cement are still intact, right? You'd have to assume that the cement has not been degraded. You'd have to assume that the steel has not been corroded. And unfortunately, many of the wells that were plugged in Louisiana and elsewhere, they were plugged before 1953 when there were some strengthening of standards for the cement that had to be used. So you can see, again, this is very much contributes to the riskscape of these technologies. Texas is yet another example. In Texas, Texas has also applied for primacy. They also want primacy over Class 6 wells. And right now, the Texas Railroad Commission oversees Class 2 wells. They are the ones that would be then overseeing the Class 6 wells if they were to get primacy. And there are some concerns there that have already been documented as well. So for example, in 2011, there was a very sharp increase in the significant non-compliance violations. And most of them are because of a failure of a mechanical integrity test. Environmental Integrity Project and Commission Shift are two organizations working in Texas. They tried to actually find out what happened, why in 2011 there was such a sharp increase in these failures of the Class 2 wells, and there was no explanation given. The other thing that has been found through some of their research is, and some of the data that the Texas Railroad Commission has revealed, is that a higher percentage of Class 2 CO2 injection wells have failed one or more mechanical integrity tests relative to other Class 2 wells. So Class 2 wells can be used for CO2. That's the kind of well that is relevant for enhanced oil recovery. And so, they are already finding problems with CO2 specifically. There's a policy kind of dynamic going on here where public subsidies are basically being provided to help the industry deal with its CO2 disposal. There's a tax credit on the books called 45Q, which was significantly expanded in recent years through some of the major federal legislation. And a 2020 government investigation found that, in fact, if you're looking at the previous decade, there were some $1 billion claimed in 45Q tax credits, and of those $1 billion claimed, credits worth $894 million actually did not comply with EPA requirements for reporting on sequestered carbon. So this is extremely problematic. This, less of a exact environmental health or justice concern, but I did want to note it because it really shows how there is significant public dollars going in to fund and pay for a problem that the fossil fuel industry has created here. And because of the expansion of 45Q, the estimates kind of vary how much would then be kind of claimed under 45Q in coming years. And one estimate from the Taxpayers for Common Sense, they estimate it to be about $4.8 billion over the next 5 years. I've seen some other estimates that are actually even higher than that. And then I wanted to talk a little bit about hydrogen, not as much. I understand that I think a previous seminar focused on hydrogen, but just hydrogen specifically in the context of the power sector, what that would look like, because the proposal is to use hydrogen, mix it with natural gas, and then burn this thing that is some combination of natural gas and hydrogen, because supposedly that would have a lower carbon footprint, right? That's the proposal on the table. And so again, there are a lot of environmental justice concerns that we have around this. So first and foremost is that the vast majority of hydrogen that we're getting today is fossil fuel derived. It's fossil-based hydrogen. It's energy intensive. There's a high greenhouse gas footprint. Even if you try to add a carbon capture operation on top of the production of that fossil-based hydrogen in what is called sort of blue hydrogen, it's still extremely greenhouse gas intensive. I will give you some numbers on that later. And of course, because it is so energy intensive and because it's fossil fuel derived, all of the co-pollutant emissions that you would get from the extraction, the use of that fossil fuels, those also apply here too. So you have the VOCs, the particulate matter, the nitrous oxides, the sulfur dioxide, et cetera. So the majority of as I mentioned, so most of it's fossil fuel-based hydrogen. It's produced in a process called steam methane reforming. So what that means is that methane leakage is definitely a concern. And in fact, because of methane leakage, because of the energy intensivity of all of this, studies have shown that, in fact, the greenhouse gas footprint of something like blue hydrogen is actually more than 20% greater than burning the natural gas or coal for heat, or some 60% greater than burning diesel oil for heat. That's from a recent study by Howarth and Jacobson. So really not a climate mitigation strategy if you think about it that way. And as I mentioned before, there are quite significant, not just greenhouse gas emissions, but also criteria air pollutant emissions that come from these steam methane reforming facilities. So this lower left-hand side graph is just estimated emissions from hydrogen production SMR facilities in the United States. You may have heard some of this discussion around green hydrogen, right, as a clean hydrogen, a better form of hydrogen. Again, let me just stress that the overwhelming majority of hydrogen being produced is not green hydrogen. Even if you were to have green hydrogen, which is hydrogen produced via electrolysis from water instead of from fossil fuels, there are serious concerns around that as well, because the production of hydrogen via electrolysis requires substantial water and energy inputs. On the freshwater footprint side, there are estimates that right now the EPA put in its proposed rule, it said something like, well, it's 9 kilograms of purified water per kilogram of hydrogen, but that's based on a theoretical calculation. That's based on, if you were to sit there like in a chemistry class and do like the equation out, and that's what that is, right? It's in practice much higher. There's various estimates, but it could be up to 22 kilograms of water according to some studies that we found. And this does not actually account for the water needs for energy and equipment used for electrolysis. So for example, for the cooling. So if you really were to use a life cycle perspective, the water footprint can be an order of magnitude greater. And of course, from an environmental equity perspective, environmental justice perspective, water scarcity is a critical issue because it causes these life-threatening localized impacts. And the water scarcity is heightened if large-scale deployment of hydrogen production happens alongside climate change, especially in water-stressed areas. Then in addition to the water footprint, the energy intensivity of green hydrogen is also potentially worrisome. So the energy estimates are quite high there, and the idea that one would use renewable energy to power this really just does not make a lot of sense, right? Why would you take renewable energy to then make this hydrogen, to then be able to burn it, to send energy to the grid? Why wouldn't you have just taken that renewable energy and had that go to the grid in the first place? Like, that's sort of a common sense kind of thing. So what we're really concerned about is that if you took away, electricity from renewables to be making something like hydrogen, you might just really be creating a more demand, and that is going to be replaced by fossil fuel generation, which is again going to harm environmental justice communities that host that infrastructure. Then, of course, there are also transport concerns. I'm not going to go too much into that, but just know that obviously because of hydrogen's very specific physical properties, right, a smaller molecular size, things like leakage, that is a higher concern. Because of its flammability, flame point, those kinds of things, there are greater consequences and risks associated with pipeline leaks and explosions. And then, of course, with the use of hydrogen, if it is going to be used in this co-firing kind of way, being mixed with natural gas, the co-firing of a blended hydrogen and natural gas mixture is going to result in higher NOx emissions than firing the natural gas alone. And that is because the flame temperature of hydrogen is higher than natural gas. So that increases the NOx emissions. So kind of every step of the way, similar to carbon capture, we see that hydrogen can also be very worrisome from an environmental justice perspective. So we focused here on the deployment of carbon capture and hydrogen for the power sector, but just know that CCS and hydrogen are really anticipated for other sectors as well, and many of the concerns that I described apply here as well, right? So the same, if you put CCS on an industrial facility, we have those same concerns about the energy intensivity of the chemical usage, et cetera. And these technologies are really key pieces to a broader carbon management paradigm that is being undertaken with significant resources, as I mentioned before, both public and private, as well as policy support. I'm not going to go into a huge amount of detail, but here are some of the buckets of funding that have been allocated to carbon management. The EPA issued, so based on a lot of these concerns, we, the Tishman Center, working with Nikki Center at Kean University, the Center for Earth, Energy, and Democracy, and other partners, we wrote a set of comments to the EPA opposing, as Nikki pointed out, opposing carbon capture and sequestration, as well as hydrogen co-firing as these systems of emissions reductions. And EPA in its final rule took our feedback into consideration, took others' feedback into consideration, and it decided to issue a rule for coal plants and new gas plants that still uses carbon capture and sequestration as the systems of emissions reduction, but it did remove the hydrogen co-firing piece. And it did not regulate the existing gas plants yet. It only regulated the new gas plants as well as all the coal plants. And we have heard that part of that, taking out that sort of existing gas plant fleet, was due in part to the EJ concerns that we raised. And we have some indications that it is also because they had some analysis kind of showing that there would be potential detrimental impacts in environmental justice communities. So the EPA right now is doing new rulemaking to figure out, well, how does it want to regulate the existing gas plants? And we are still kind of in the same posture of opposing CCS and trying to argue for different types of technologies. We are also arguing for stronger cumulative impacts and environmental justice analysis to inform their decision making. There are a number of other projects that are part of the kind of carbon management paradigm. So I just want to mention a couple of them. You have hydrogen hubs, $7 billion being moved forward for 7 regional hydrogen hubs. DOE is, so this is basically, if you think of like the different kind of funding streams for carbon management, we have the tax credits, Department of Treasury on the one hand, and then you also have large buckets of funding that DOE is kind of investing and acting like a catalytic investor. And they're really trying to get hydrogen and CCS and all these other technologies to a point what they're calling commercial liftoff. So they're very much actively promoting them and the projects. Another example is the industrial decarbonization hubs, 33 projects in 20 plus states. Many of these projects involving CCS and hydrogen as well. In all of the DOE projects, there's this point where they say that, hey, there's supposed to be community benefits plans, there's supposed to be a commitment to engage the communities, and that is sort of what is pointed to as the environmental justice kind of backstop or protection. And unfortunately, they have not been upfront and seem to refuse to consider that communities should have a right to refusal. So it's really only this kind of process, if that. We've seen problems even with the process, where folks are showing up to meetings without adequate information, without adequate notice, without getting answers to their questions. So all of this is also very concerning. So much so that the White House Environmental Justice Advisory Council, in October of 2024, just recently, they actually advised the DOE to suspend the use of these community benefits agreements and community benefits plans until more of the impacts and risks were really fully known and disclosed to the public. And just a really brief recap, these are the concerns. You're placing risks on already overburdened and vulnerable communities. There are significant risks that get exacerbated because of the regulatory insufficiencies. The CBAs, the community benefits agreements, and the community benefits plans are just not sufficient protection to mitigate harms in the way that they're currently being used. And of course, all of this against the context that the carbon capture sequestration technology has not produced the capture rates promised and extends fossil fuels while using significant public funds and adding risk. A few additional resources. I have here the white paper, a couple sets of recommendations. on the from the White House Environmental Justice Advisory Council, as well as the comments that we put together on the proposed power sector rule. Okay, thank you very much.
So we do have time for questions until 1:30? 1:15. Okay, we have time for a few questions. So folks, don't be shy. Yes, sir.
Hi. So I noticed you put on one of the slides that many academic institutions are involved in hydrogen hubs. Would you be able to expand on that if that's like a problem as well?
Yeah, I think so the participation of academic institutions is something that we've noticed when you look at the project collaborators for the hydrogen hubs. They, like many of them, mention academic partners. And what we are concerned about is that the funding for the research is really coming from one side, right? It's either from DOE, from the government that is already taken on the role of investing in these technologies, or from some of these same fossil fuel companies themselves. And we are worried about kind of the transparency and whether or not they're really out there looking for the risks, or whether they're there more to promote the technologies. Another thing that I will also mention is that the DOE has also put out this call, and the National Academies of Science as well, to really try to get social scientists involved in what they're saying is equitable decarbonization. And what I think concerns us is that many social scientists are not quite as aware of this landscape, and yet they're kind of being like beckoned to participate on the idea that, hey, you have some experience with community engaged research, right? Like, we are hard scientists, we do not, but you as social scientists, you've had some experience doing community-based participatory research or whatever else. So tell us how we can get communities to say yes to these projects. That's a little bit of the concern that that we're seeing play out. So, so yeah, did I answer your question? Yeah. Those two. Mm-hmm.
Yes, sir.
Maybe a bit more channel. So I'm a solar energy researcher, so I'm biased in my view on energy, I guess. It seems to me, as a non-expert in your field, that kind of discussing about CCS, discussing about hydrogen, often seems as a kind of method by fossil fuel companies to stay in business. And governments cooperate with them and do a lot of talk about hydrogen. The German government come from hydrogen economy, where views on this are getting more and more critical. While the obvious solution, expanding wind and solar and investing in storage and electrifying mobility and heating, which plays probably the biggest role in bringing down fossil fuels, in the discussion has a much smaller role than it in real life has. So with your view and also your view on law, and how do you think, how should we as academic community address this balance?
Yeah, that's a really good question. I mean, I think you're very much right. And I think there are different types of academic research, right, that could be illustrative. You're absolutely right that the fossil fuel industry is very invested in carbon management. And we have documented and seen studies that show, their support, for example, of lobbyists and pro-CCS like legislative actions. They have been there. I think one of the things that is important from the academic point of view is that a lot of the modeling, for example, even the modeling that the EPA uses, just uses these ridiculous figures, like the 90%. They didn't actually even use a lower assumption of a carbon capture rate. So that's where I would love to welcome academic colleagues to take a closer look at those highly technical things, for example, the highly technical analysis to say, you didn't evaluate that properly. Or what were the other cases that you evaluated, right? What were the other options? One of the things that we proposed, especially like you're mentioning with the solar, we actually did say to EPA, and we are continuing to say to EPA, that something like battery storage with renewables could be a better system of emissions reductions, and we want the EPA to consider that. And EPA had come back to us to say, well, that's not as well demonstrated, right? As if the CCS case was very well demonstrated. So that's, again, another field where I would very much invite the academic researchers who know more about the solar. They were saying to us things like, well, the solar and the battery storage, it's not going to make sense for plants that operate more of the time. It's only going to make sense for some plants that, like peaking plants, for example, or like very little of the time. And that's where I think there could be some like negotiation and bringing forth data from academic researchers to help make the case. Yeah.
So I'm kind of curious about like the injection sites. I was under the impression that carbon could be permanently stored under the ground. I don't know a lot about this, but these sites off Norway have a lifespan of like you said 15 years. So I'm curious about like, are there optimal sites? Is there a way to choose a good site? Is there are there just no good sites because someone will always be negatively impacted?
Yeah, I think with the sequestration and the geologic sequestration, which is storing it underground, it's one of those fields where the permanence, the duration of storage is a really big question. It's still not really known how long, and even if you were to say like, oh, it could stay there for 40 years, that's actually still not a climate solution, right? Because if eventually it goes up into the atmosphere. And what we were trying to do is even to understand how far along the science was, we went to look at the documentation, we looked at the Department of Energy, because we were actually trying to do this co-location analysis to say, okay, well, where are anticipated storage sites? Where are they in relation to EJ communities? And what we found were these maps of anticipated locations that's like, it's like the whole entire region like is shaded, it's like there's no specificity whatsoever. So that's very concerning, right? And so I think it's like of the kind of places in kind of the supply chain, it's one of the biggest knowledge gaps is like where you can put it. Is it going to contribute to seismic activity? Is it going to affect like groundwater sources? I mean, that is one of the reasons why it's regulated right under the Safe Drinking Water Act, is because you also have underground sources of water that could potentially be impacted by any CO2 that kind of migrates away. Yeah.
I'm a little bit curious about the ways in which some of these modes of disadvantage are likely to interact with each other in the future. You talked about them relatively distinctly so far as part of your talk, but are you able to give any insights into the ways in which things like pipelines and carbon the filtering processes are likely to interact with each other to create different disadvantage, or are they still likely to remain distinct for local communities and some CJ communities?
Yeah, that's a really good question. I don't really know the answer to that, because I think a lot of it's going to depend on like the build out and how far away like sites of, say, if you're using the hydrogen or storing the CO2 or whatever, how far away they are from like the sites of where you're doing the capture, right? Like in some cases, like if it's for geologic sequestration, I was reading that it's like, oh, it's probably going to have to be transported quite far away, which is why you have that extensive pipeline CO2 network anticipated. So I'm not really sure in terms of the interaction, but what I will say is that like when it comes to disadvantage, there are pre-existing burdens on those communities right there, right? I didn't really talk about this, but obviously the communities that are living near the power plants, they're probably not just living near the power plant, they probably live near other legacy pollution, they live near infrastructure, highways, right? Like unremediated land, hazardous waste facilities, Superfund sites, like all of this kind of thing. So we know for sure that that has an interaction because it is the same, community that's kind of living with those multiple burdens. So I think for us, like we have been focusing a lot of our attention on saying like, hey, you need to have a sort of cumulative impacts accounting for where, even if you were to say as EPA, we propose their CCS on power plants, like, well, maybe don't do that in places that are already cumulatively impacted by environmental and social burdens. So that's been a big like policy ask that we've been putting forward.
So I just want to thank
Yeah,
Dr. Lam for coming and taking a day. A day is a long time for us. We're out of a very busy schedule. She's talked to people this morning. And I just want to thank you very much, Dr. Lam, for coming and giving us a point of view that I think still is not often heard a lot.
Thank you.